One form for an equation of a line is point-slope form. Point-slope form is beneficial because you can easily see the slope of the line and a point on the line. Not necessarily the y-intercept, but any point on that line. You will see that m is still designated as the slope of the line in this equation, just like in slope-intercept form. And when we're referring to slope of a line on a graph, we're going to use the definition of rise over run. A point on that line is being symbolized as x1 and y1. x1 is the x value of the point, and y1 is the y value of the point. So x1, y1 is a point on the line. Like I said, this can be any point on the line. Does not necessarily have to be a y-intercept, an x-intercept. It can be any point on that line. So there are actually endless amounts of point-slope forms of a line. When asked to write the equation of a line that passes through these 2 points, we cannot use slope-intercept form because we do not know what the y-intercept is. We can use point-slope form though. But first, we need to find the slope of the line because point-slope form uses the point and the slope of the line. To find slope between 2 points that are not on a graph, we're going to use the definition of change in y over change in x. So my change in y going from 3 to 10 is a positive 7, and my change in x going from 2 to 5 is a positive 3 change. So the slope of this line between these 2 points in change in y over change in x is 7/3. If I follow point-slope form of y minus y1 equals m times x minus x1, I need to fill in 3 values. The slope, which is going to go in m's spot, the x value of that point, which is going to go in x1's spot, and the y value of that point, which is going to go in y1's value. You will notice, as I've highlighted, that we have 2 points that we have been given for this line. So we can use either point for the point-slope form of this line. If we choose to use the point 2, 3, we would plug 2 in for x1 and 3 in for y1. This would give us the resulting point-slope form of y minus 3 equals 7/3 times x minus 2. Or we could choose to use the point 5, 10. If we choose that point, we would have the point-slope form of y minus 10 equals 7/3 times x minus 5. Both of these are examples of a point-slope form of that specific line. If I am asked to write the equation of a line in slope-intercept form when I'm given 2 points, I still need to begin my process in point-slope form. The only way that I can write an equation of a line directly in slope-intercept form is if I was given the slope and the y-intercept. I am not given the y-intercept of this line, and I cannot calculate it with just these 2 points. But I can find the slope and use one of the points, start in point-slope form, and then do some simplifying to give a resulting equation in slope-intercept form, which is that y equals mx plus b. Once again, we do need to find the slope of the line between these 2 points. My change in y would be a positive 9, and my change in x would be a positive 3. So the slope of this line, change in y over change in x, is 9/3, which simplifies to 3. Once again, following this point-slope form of y equals y minus y1 equals m times x minus x1. Just as before, I am able to plug either one of these x values in for x1 and either one of these y values in for y1 for my point-slope form. And then once again, m stands for slope, which we'll plug 3 in for m's spot. If I choose to use the first point of -4, 5, my point-slope form of my equation would be y minus 5 equals 3 times x minus a -4. My first step in simplifying is that a negative times a negative is positive, so the expression of x minus a -4 is really saying x plus 4. As we look at slope-intercept form has y by itself. So in order to get this point-slope form into slope-intercept form, I'm going to simplify it and get y by itself. My first step is to use the distributive property. This will leave me with y minus 5 equals 3x plus 12. And my last step to get y by itself is using an inverse operation of adding 5 to both sides. This leaves me with the equation of y equals 3x plus 17. Now, I stated before that we could use either point to start in point-slope form. So if we would choose to use this point here, our point-slope form would be y minus 14 equals 3 times x minus a negative 1. Just as before, I have a negative times a negative, so this changes into a positive. I can still change this point-slope form into slope-intercept form by simplifying it first with the distributive property, and secondly with some inverse operations. And you will notice that as I simplify this point-slope form, it also leaves me with y equals 3x plus 17. Both of these point-slope form equations are the exact same lines. They are just different unsimplified forms of that slope-intercept form. In order to graph an equation in point-slope form, I first need to find the x1, y1 point. Once I discover that from the point-slope form, then I can use the slope to rise and run from that point. As I look at this equation, following the form of y minus y1 equals m times x minus x1, my first step is that I'm going to rewrite this part of the equation as a subtraction. I can see that 1/5 is the slope of the line. I also can see that the y1 value is 2 because it's minus the y1 value. The minus sign is a part of the equation. And that x minus x1, my x1 value is negative 8. So the point on this line is negative 8, 2, and my slope is 1/5. When I think about slope on a graph, I'm going to use the definition of rise over run. So a slope of 1/5 would tell me to go up 1 and 5 to the right. My first step is to plot the point negative 8, 2. Then using the slope of 1/5 to rise and run would leave me with a line that looks like this. In the second equation, once again, I'm going to rewrite so that I see a difference in both the x and the y values. We now can see that the x1 value of this line is 6, the y1 value of this line is negative 3, and the slope of this line is negative 4. So I know that the point 6, negative 3 is on the line, and I also know that negative 4 is my slope. So this slope tells me to go down 4 and 1 to the right. I also can go up 4 and 1 to the left because that would still be a negative 4 slope.